So this is the back page. So this was something that you were to complete after reading pages 128 and 129 in the textbook. And so just going over as a review here, getting us ready for our next topic where we go into acid and base ionization constants in a little bit more detail. So to start, we have the question, what is an acid ionization constant? Well, it is... it's the KEQ for a reaction between a weak acid and water. It is important that it is a weak acid because an equilibrium will not be established between a strong acid and water. Okay, and then at the same time, what is the base ionization constant? Well, it's the KEQ for a reaction between a weak base and water. For the acid equilibrium constant, we give it the symbol Ka. For the base, we give it Kb. Okay, well, so this next question is saying, okay, pick an acid from the table, a weak acid from the table, relative strengths of acids and bases, and find the acid ionization expression for this acid. So first of all, I'm going to write the equation for this reaction. So I'm going to say the acid I'm going to pick is H3PO4, so phosphoric acid. So it's going to be aqueous. And so as we said above, this is the KEQ for a reaction between a weak acid and water. And so in this case, phosphoric acid is reacting with the water, and the phosphoric acid is acting as the base, so it's giving up a proton. So it's going to be H2PO4 negative now. That's getting one more positive. And then the water is accepting the proton to become hydronium. And if we look at the KEQ for this, we're going to call it Ka. And it's equal to the concentration of H2PO4 multiplied by the concentration of hydronium all over the concentration of H3PO4. And we do not include water in that expression. Now this next question saying we're doing the same thing but with a base. So the base that we'll pick here is sulfate. Well, sulfate reacting with water. Sulfate is acting as the base, so it's accepting the proton from water. So water in this case is acting as the acid. So we end up with HSO4 negative plus hydroxide. And in this case, we're going to call it Kb. And it is equal to the concentration of HSO4 negative and multiplied by hydroxide, all divided by the concentration of sulfate. Oops. Okay, and we'll get into some more detail on those things, or Ka and Kb, in the next notes package, and when you test out the PhET simulation. But if you had two acids with different Ka values, how you can tell which one is the stronger acid? Well, simply the one with the larger Ka value is the stronger acid. It is easier for it ionizes more in water than the other. And you can tell because on the top of the fraction for Ka up here, for example, the higher the Ka value, the higher the concentration of hydroxide in solution. And if you have two bases with different KB values, how can you tell which one is the stronger base? Well, the one with the larger KB value is the stronger acid. Sorry, stronger base. The base, in other words, you could say this the same. Means the same thing. The base with the weaker, conjugate acid is the stronger base. Now, the reason why I say this is because, well, when we look at the table of relative strengths of acids and bases, it only gives us the Ka value. So the base that is further up the table has a conjugate acid with the stronger conjugate acid, and therefore the weaker base. The further up on the table you see the base, the weaker it is. Okay, well, so the next thing to do would be to go to the Google Classroom and complete the assignment for the PhET simulation. Good luck, and I'll talk to you on the Zoom call later on in the class.